So, question 10. An inclined plane. A particle is placed of mass 10 kilos. So I have 10g towards the center of the earth. Inclined plane. Angle A to the horizontal. I have my oar. And is there a rope or anything involved here? It's pulled up the plane by means of a string, which makes an angle B with the plane. Okay, so the string is going up in this direction. And there's an angle B in here. And we can pull with a force of 130 newtons in this direction. 130 newtons. So that's my basic diagram. So let's have a look at putting some more information into the second diagram. So we have, well, let's get, actually, what we'll do first, we'll get the cos of A and the sine of A. So the tan A is 3/4. So we have O over A, so cos A is going to be 4A over H, and sine A is going to be O over H. We also have cos B and sine B. Tan B is 5/12, so the O part is your sine, so 5/13, and the A part is your cos, 12/13. Okay, so we have our angles. So now let's do a bigger diagram here. So we have several different things going on here. We have our particle. We have oar. Actually, I won't color it in. We have oar. We could possibly have mu oar. We have smooth first, but we could have mu oar going down this way. We need what's going down this way and this way, and this was obviously in relation to your angle A, which was in here. So in this direction we have opposite A, so we need the hypotenuse, which was my 10g, so we have 10g sine A, and sine A is 3/5, so we have 6g, and in this direction we have 10g cos A, which is going to be equal to 4/5 8g. I also have, I need to know what's going on in that direction and in that direction, and this is where we had the angle B. So over here my hypotenuse is 130, so opposite B, 130 sine B is equal to, well, the 13 will divide in, so leave me with 50 newtons. And this one is going to be 130 cos B, which is going to give me 120 newtons. So I think that's all my arrows. Can I resolve these forces? We're looking for acceleration first. So my resultant force is equal to ma. So the particle is pulled up the plane. So to resolve my forces, I start in that direction and I take away what's happening in that direction. So I'm going to color in my arrows. I said I wasn't going to color them in, so I can do it now. Just make sure we include them all. So that 120 minus this one here, what's this one? 6g is equal to m, which is 10 times a. So 120 minus 6 times 9.8, 60 minus 1.2 is 58.8. That's 10a. So that's 61.2 is equal to 10a. So this, you can get my acceleration to be 6.12 meters per second squared. So that's the acceleration if the plane is smooth. If the plane is rough, we have this mu r. So I do have a reactionary force along here. So let's add it in. What's mu r going to be? Mu r. That's what we want. Okay, so what can we say? We're going to have to calculate r. So r, and then also in this direction, r, and this guy here, which is 50. So I'm going to have to say r plus 50. or plus 50 equals, what have we got going down? See one here, this one here, or plus 50 is equal to, what's that one? 8g. So or plus 50 is equal to 8, 9.8, 80 minus 1.6, 78.6. So or is going to be 28.6 newtons. So mu or is going to be, what do we got mu to be? A quarter. So 28.6 divided by times 1 over 4 divided by 4 is 7.1 newtons. So now I have an extra force to add in. So what have I got? I still have this one. I'm going to color them in green. I have 120. But now I need to take away mu or 7.1, as well as this 6g, which was 58.8. Just double check they're the only ones we need. The only other two R's were up and down. So that's my resolved forces. That has to be equal to mass times acceleration, which is 10 times a from before. So instead of having 61.2, we have to take away an extra 7.1, so 54.1. 54.1 is equal to 10a. So my acceleration is 5.41 ms squared. And that's it for question 10. Okay, question 11. Finish off 5b here before moving on to these connected particles going around pulleys, which are lovely questions. A particle of mass 2 kilos is allowed to slip down a smooth slope. So here's my slope. Here's my particle of mass 2. So going down in this way, I have 2g. It's going down the slope, so we could have mu or in that direction. We'll check now. I have a reactionary force, and it's angled at a net angle A. So I've got my A in here too. And we're told sine A is equal to 1 over 5. Okay, that's my diagram. So we're told sine A, we're going to need cos A here, cos A. So if sine A is 1 over 5, opposite over hypotenuse, the square root of 25 minus 1 is the square root of 24. Cos A is equal to the square root of 24 over 5. Okay, let's do a new diagram for this one. I'm going to put our force in. We're actually keeping it in terms of g here. You can see, show that the acceleration is a fifth g, and the normal reaction between the particle and the slope ground is 4 root 6g over 5 newtons. Okay, we'll put our new values in here, keep it in terms of g. So I have my block. We know this one is 2g. So this one along here, straight down, opposite my reaction, is going to be 2g sine A, opposite, no, 2g cos A. This one going back in this direction is 2g sine A. It's going down the slope, so in this direction I have mu or, we're told the coefficient of friction, and in this direction we have my reactionary force. So there's nothing else I don't think here, so let's have a look at resolving these forces. Just give myself a bit of room. So if we start with or, I'll colour them in red this time just to make sure we oppose them. Or goes up and 2g cos alpha goes down, so or is equal to 2g cos alpha. We're told something about mu. We're told mu, and I'll show the acceleration is 1 over 5g. Show the acceleration is 1 over 5g, and the normal reaction is 4 root 6g over 5. So if we start with or is 2g cos alpha, we can get or is equal to 2g by root 24 over 5. So or is equal to 2 root 24 times g over 5. And 2 root 24 is the square root of 20. Square root of 4 by square root of 24 is equal to square root 96, which is equal to 16 root 6, which is 4 root 6. So this is 4 root 6g over 5 for the normal reaction. I think that's what we were asked, wasn't it? The second part. The normal reaction, 4 root 6g over 5. And actually we'll go back and get the acceleration then. We've done it kind of the other way around. But we have the normal reaction. So if I resolve my forces, what are my resolved forces? F, we have in this direction, well, it's going in this direction, so I got to start in this direction. So I have 2g sine alpha. And do I have no mu in this case? I just have 2g sine alpha. No mu. No mu. Okay, so 2g sine alpha is the only arrow going down that way. There's none of this. So 2g sine alpha, there's nothing to take away. That's F is equal to ma. The mass is m. Let me tell the mass is m. Just double check. It's not 2 kg. 2 kg, which I did. Oh, I put it in here. So 2a. So sine alpha, we were told was, what was sine alpha? 1 over 5. 2g by 1 over 5 is equal to 2a. Dividing across by 2, I get g over 5 is equal to acceleration. What did we have? 1/5 g. Yeah, it's the same thing. A is equal to 1/5 g meters per second squared. So that is question 11. And we'll go on now to look at systems of connected particles, which you can see coming up next.